Okay, Foundations Pre-Cal 10. Let's get after it. Here we go. We have a video on function notation. Now, oftentimes this is glossed over in grade 10 because we just run out of time, but I actually think it's incredibly important because when you get into Pre-Cal 11, 12, and then calculus and further up, you only use function notation. So it's something that I want you to try to wrap your heads around here as best you can. So first thing I want you to realize is this is function notation. F of x, we call that, instead of saying y. But they're synonymous to one another. They mean the same thing because originally when we think independent dependent variables, this would be our input. We would input a value for x like how we did here, right? Like when x is 0, we would have y equals 3 times 0 plus 5, y equals 0 plus 5, y equals 5, right? We would get that, right? X is our input, and then we end up with our output. And our output is our y value. So function notation takes that and keeps it the exact same. It's just instead of calling it y, we call it f of x. That's still our input, and f of x becomes our output, and f of x is our y. But it's just written in form of the function, not with respect to the letter y. And how function notation works is we could do the same question here to do an input-output, and instead of writing 0 equals, you put f of 0. So you can see I substituted the 0 for the x, which means anywhere in the equation I see an x, I substitute a 0. And you just end up in the same thing. F of 0 equals 5. So what it means is the function, the output of the function is equal to 5 when the input of the function is equal to 0. So it's the same thing. So then let's do another. F of 1 would give us 3 times 1 plus 5. So f of 1 would give us 3 plus 5. F of 1 would give us 8. So it means when x is 1, y is 8. So you can see that that's how function notation works. Let's do 2 more just to fill that table, and we can pick any value we want. Let's go, well, what about f of 7? What if I wanted to know what the y value was when x was 7? Well, then I'd write 3 times 7 plus 5, which gives us 21 plus 5, which gives me 26. So it means when x is 7, y is 26. And we can do one more, and we will do one more. Let's do, okay, what about f of negative 2? So what is my output when my input is negative 2? Well, I just sub in negative 2 for x, and I end up with negative 6 plus 5, which is negative 1. So there I am. When x is negative 2, I'm at negative 1. And remember, those are all points we can find on our grid. So in this question now, you can see, what about when f of x equals 7? Well, that's the same as saying f of x equals y. Well, then when y equals negative 7. So if you have this scenario when f of x equals something, you sub it in right there for f of x. So that is our output, right? We get negative 7 equals negative 2x plus 5. And what we do in this case is now we solve for x because we're given the output, we're given the y value, we're given the f of x is equal to value. So we're solving for the input. So we're just going to do our algebra, subtract 5, negative 12 equals negative 2x, divide both sides by negative 2, and x is equal to 6. So the coordinates of our point are 6, negative 7, right? So we're done. F of x equals means what's your output, what's your y value? Otherwise, you're solving for x. And you know me, things always get harder. So it's important to consider that we are substituting for x whatever gets replaced in the function. So let's do both of these. So for the first one, we have f of x equals 5x minus 2. And we have an x, right? We have an x right here, we have an x right here. But what's happening is we're saying, what about f of 3x? So that means that wherever we saw an x, it now becomes a 3x. So you substitute what gets substituted into the function in for the original x values. And then you just solve it how you would. So f of 3x is equal to 15x minus 2. And we actually can't do anything more than that. That's all we can do. So that is your answer. F of 3x is equal to 15x minus 2. And that's where you're at. Understanding how and when to stop is important. So what about the other one here? So again, we have f of x equals 5x minus 2. That's our original function. And we are changing our input values to x minus 2. So this becomes, well, what is f of x minus 2? Well, it is 5 and then times x minus 2 and then minus 2. So in this case, that 5 is multiplying into both of those things. Water bombing, 5x minus 10 minus 2. So we get 5x minus 12. So f of x minus 2 is equal to that. And this changing your inputs is going to have implications in transformations of graphs in grade 12. So because you'll be given an original function, right, that you will graph somehow, whatever it looks like, right? But then they'll change that function and it might look like this. And there are particular things that those substitutions into your function are doing to your graph. So that's where this has its roots. So it's good to get a handle on. That's why I really wanted to make sure I show it. Now here, I say it has whispers of calculus because this is actually the equation to determine the limit of a function. And don't worry about what that means. If you really want to, you can go to my calculus videos once they're posted and you can see how this works out. But it's the same thing. See, we're given what f of x equals. Okay? And you can see in the equation we have minus f of x. So we will have minus 3x. It's important to think about what happens if you have a multi-termed function. So if you have that, because it would be really important to put brackets around it because you're going to be subtracting everything. That's a common error. But in this case, we only have the 3x. So we're going to have minus 3x. Now the other aspect of this is f of x plus h. We're going to do the same thing we did last slide, where we're just going to substitute the x for x plus h. So we have that. So if you look at f of x plus h minus f of x, it means we have 3 times x plus h minus 3x. That's f of x plus h minus f of x, all divided by h. And in this case, it doesn't matter what h is. In calculus, we are taking the limit as h goes to infinity, or no, as h goes to 0. But again, please don't worry about that right now. All we know is h does not equal 0, because if it did, we'd have a 0 denominator and it would be game over. But all we do from here is we can simplify out. So water bomb that in, 3x plus 3h minus 3x all over h. Well, the 3x minus 3x is 0, and you're left with 3h over h, and h divided by h is 1. So you're left with just 3. And you'll see what that means again once you get to calculus. Here's one more, and here's an example of a function that has multi-terms and why it's important to use brackets. So again, f of x is that. Well, what is f of x plus h then? Well, f of x plus h is going to be 3 times x plus h minus 4. So why do I make a big fuss about multi-term here? What do we mean that there's two terms, right? Two term. You have f of x plus h, which we solved out as 3x plus h minus 4. So that's this bit. And then minus, and now here's the thing, we're subtracting 3x minus 4. But if you write it like that, you'll subtract the 3x and you'll forget to subtract the negative 4. So put brackets around that term. And then divide by h. And then simplify out. So times, and then remember, water bomb the negative end. So 3x plus 3h minus 4 minus 3x plus 4 all over h, and we'll simplify. So 3x minus 3x, negative 4 plus 4, and again, we're left with 3h over h. And the h's will cancel, and we're left with 3. The what's called derivative of 3x minus 4 is 3, which is exactly what we calculated in a long form here. And again, you learned this in Calculus 12. Yeah, something to look forward to. Woo! So that's function notation. Remember, there's notes in section 3.5. We just kind of barely look at it in grade 10 because it's more important to understand the function input-output than it is to understand those big last two slides. But I definitely wanted to show you how the substitution works because it will come in handy. And hey, better to know than not, right? Okay, good job. Keep it up.